So today, I just want to do a little bit of a review. Because today, Mr. Stuckey and I, we graded your solving cubic equations assignment, and we noticed a lot of you were making the same mistake over and over. So we wanted to re-teach you this concept. So we were solving equations like this. 27x cubed minus 1 equals 0. Some of you solved it correctly, but there wasn't too many of you that solved it correctly. This is, here's how most of you did the problem, okay? So a lot of you took this equation, you saw 27x cubed minus 1 is equal to 0. What you did first was you added 1 to both sides. This is a good start, okay? I don't blame you for doing this. And you end up with 27x cubed is equal to 1. And then the next step you did was divided both sides by 27. And you got x cubed is equal to 1 over 27. And then, I'm assuming this is what you guys did. What you did next was took the cube root of both sides. You solved it as if you were solving a quadratic equation in which you can use the square root method. And then you got x is equal to the cube root of 1 over the cube root of 27, which reduces down to, well, the cube root of 1 is 1, and the cube root of 27 is 3. And you get 1/3. Okay? This is a root to this equation. This is a solution to that equation. But my directions ask you to solve all of them. It said find all the roots. Well, you might be asking yourself, how many roots does this equation have? You should know the answer to that question, because what's the degree of this equation? The degree of this equation is 3. So this is a third degree. This is a cubic equation. That means the degree tells you how many roots it has. It has 3 roots. How many roots did you find? 1 of them. I want you to find 3 of them. So the method I wanted you to use was to factor it. Because what we have here, this 27x cubed minus 1, that's a special case. That's called a difference of perfect cubes. And my video that was attached to the lesson showed this. If you watched that video, you should have done it the way I asked you to do on the video. So we're going to give you a second chance at this. So I'm going to show you once again how to do this. All right, so over to the left side here, I got these 2 equations. Both of these equations have some similarities. This is how you can factor a perfect cube, a sum or a difference of perfect cubes. What I have at the top one, a cubed minus b cubed, that's called a difference of perfect cubes. Why a difference? Because we're subtracting. Down underneath, a cubed plus b cubed, this is called the sum of 2 cubes. Sum of perfect cubes. Why sum? Because we are adding. Okay? Whenever you have a sum or difference of perfect cubes, you can factor it. And they factor very similar. Okay? Notice this expression here and this expression here are both a binomial. And then this expression here and this expression here is a trinomial. It's the same. The only thing that's different about these 2 expressions are the signs. All the letters are the same. The binomial has a and b on both of them. The trinomial has a squared first, and then ab in the middle, and then b squared. They're the same. So you just got to remember the order of the letters. It's ab, a squared, ab, b squared. Okay? Then you have to get the right signs. But to get the right signs, remember, we use this word SOAP. So if you use this word, this will help you remember what signs to use. Okay? Let me explain. The S in SOAP stands for the same. So whatever sign you started with originally, it's going to be the same sign. So right here I had a minus sign, right there, got a minus sign there. Down here I had a plus sign, had a plus sign there. Now if S stands for the same, what do you think O stands for? It stands for the opposite. Okay? So now you're going to have the opposite sign. We had a minus sign, the opposite of minus is plus. Down here we had a plus, the opposite of plus is minus. And then the only one that might confuse you is AP. Well, AP stands for always positive. Always positive. Okay? That last number is always a positive number. All right, so now let me show you how you should have solved this problem. This is how you should have solved it. This is how you can find all the roots, not just one of the roots. This is the method that I wanted you to use. So I'm going to give you a second chance at it. So make sure you're using this method I'm getting ready to show you. Solve it like this, okay? So here's what we're going to do. What we're going to do is we're going to factor this side. We're going to factor 27x cubed minus 1. How we're going to factor it? We're going to use this. All right, we're using these. What do we got here? We got a difference of perfect cubes. So here's what I'm going to ask myself. What number or expression can I take times itself 3 times to get 27x cubed? Well, that expression is 3x. If you take 3x times 3x times 3x, what does that equal? That equals 27x cubed. Okay, so I'm going to rewrite 27x cubed as 3x to the third power. And now we're going to try to do a similar thing with the 1 here. What number can you take times itself 3 times to get 1? Well, 1. So 1 can be replaced as 1 to the third power. So what we have here are A's and our B value. So this 3x is my A value. This 1 is my B value. Okay? So we're using this format since it's a difference of perfect squares. So we're going to have A minus B times A squared plus AB plus B squared is equal to 0. What is our A? A is 3x. So wherever you see an A, you're going to put 3x. All right? So here's an A. Here's an A squared. What's another way to think about A squared? Well, that's A times A. So what is 3x times 3x? That's 9x squared. Okay? Let's do our B. Our B is 1. So for B, we're going to put 1. Well, I got a B squared. What is B squared? That's B times B. So I'm going to put a 1 here. So how do I get the middle term, the AB? Well, you take 3x, which is your A, times your B, which is 1. What's 3x times 1? That is 3x. Let's put our signs in. We have minus, plus, always positive, right? So there's how it factors. This is how I want you to solve these problems. So now, let's finish this problem. So I'm going to put this down to one screen so you can see the work better. So we need to solve this equation here. We got it factored. I just want to solve it. All right, so once you have it factored like we do, what you do is you take each of the factors and and set them equal to 0. So we're going to take 3x minus 1, set it equals 0. We're going to take the factor 9x squared plus 3x plus 1 and set that equal to 0. And what we're going to do is we're going to solve these two equations. These two equations are going to give me the roots of my cubic equation I started with. So here we're going to add 1 to both sides. We get 3x equals 1 divided by 3. So we get x equals 1/3. That's one of the roots. Now over here, what do we have? What type of equation is this? This is a quadratic equation. It has degree 2 because the largest exponent is a 2. That's the degree. So this equation should have 2 roots. This equation over here had 1 root because this is to the first power. 1 plus 2 is 3. So we'll have 3 roots. So how do we solve this equation? Well, anytime you're doing these problems, this expression over here, your trinomial, what you're going to have to use to solve it is the quadratic formula. So again, if you forgot the quadratic formula, there it is. How do you get the values of a, b, and c? Well, you get that from the standard form. The standard form is ax squared plus bx plus c equals 0. So as you can see, a is 9, b is 3, and c is 1. So we're just going to plug these values into the quadratic formula. So we have the opposite of b. Negative b means the opposite of b. So we got 3. The opposite of that would be negative 3. Plus or minus b squared. So 3 squared is 9. Minus 4 times a. A is 9. Times c. C is 1. All over 2 times a. And a again was 9. So now, let's clean this up. We got negative 3. We got 2 times 9 is 18. So on the bottom we got 18. We got to figure out what's under the radical, the discriminant. So what do we have underneath the radical? We're going to do order operations. According to order operations, you're going to have to do your multiplication first. So we have 9 minus 4 times 9 is 36 times 1 is 36. So we got 9 minus 36. That's 27, right? Negative 27. So we get negative 27. So here's our answer. But this answer is not simplified. So now we just got to simplify the answer. So we got to reduce our square root. Well, the first thing I notice is there's a negative under the radical. So you're going to pull out the square root of negative 1. Now, if you pull out the square root of negative 1, the negative 27 becomes positive 27. Is there a perfect square that divides 27? Yes, 9 does. How many times does 9 go to 27? 3 times. So here's going to be our answer. We got the square root of negative 1 times the square root of 9 times the square root of 3. The square root of negative 1 is I. The square root of 9 is 3. And then the square root of negative 3, you can't reduce that. That's just the square root of negative 3. So how we write the answer is 3i times the square root of 3. So you reduce your square root first before you cancel anything out on top and bottom. Now, once you got your square root canceled out, that's when you look at the numbers that are on the outside. It should always be 3 of them. If there's a number that can divide into all 3 of these, reduce it. If there's a number that can only divide into 2 of them, you don't reduce it. You can't. You just leave it alone. So what can we divide out of all 3 of these? 3. So that becomes 1, 1, 6. All right, so what are the roots? What are the roots to this equation? Well, way back a long time ago when we started this problem, we found one of the roots right here is 1/3. So one of the roots is 1/3. Should have 3 of them. Well, what are the other 2 roots? Well, we have it right here. The other 2 roots are negative 1 plus 1i radical 3 over 6. And then the third root would be negative 1 minus 1i radical Radical 3 over 6. How many roots do I got? 3 of them. So I'm going to give you another problem like this on today's assignment. I want you to find all the roots. I want you to use this method. I want you to factor it, say each of the factors equal to 0, solve the second one by using the quadratic formula, and make sure you show all your work. I need to see the work if you want to receive full credit.